Okay, it is given that 1, x power 2, x power 4, x power 6 is a geometric progression and its sum to infinity is 3. Find the common ratio in terms of x and the positive value of x. Okay, now we are going to find the common ratio. So here, by using the term given in the question, we can substitute the term into the formula and then we will get the common ratio. Now here I'm using the third and the second term, which is x power 4 and x power 2. And we will get the answer is x power 2. For the next question, we need to find the positive value of x. We can find it by using the formula s infinity equal to a over 1 minus r. From the question, we know that s infinity is equal to 3 and a is 1, as a represents the first term. And we also know that r is x squared. So all we have to do now is substitute the information into the formula and we will get 3 is equal to 1 over 1 minus x squared. And then we will proceed the calculation until we will get the x as the subject of formula. And we will get x is equal to plus minus square root 2 over 3. As we know from the question wants us to find the positive value of x. So we need to take the positive value of square root 2 over 3 as the value of x. And lastly, we will get the answer is square root 2 over 3, or in decimal is 0.8165.
The third term of a geometric progression is 16. The sum of third term and fourth term is 8. Find A, the first term and the common ratio of the progression, and B, the sum to infinity of the progression. For the first question, firstly we need to find the fourth term. After we find the fourth term, we can find the common ratio of the progression, which is r equal to negative 1 over 2, and then substitute r into equation a equal to 16 over r squared, and you will get a equal to 64. And for the second question, use the formula of the sum to infinity and you will get 100.
So, express the repeating decimal 0.2525 in the form of sum to infinity of geometric progressions. Hence, express the number in the simplest form of fraction.
First step, we separate the number into the form of a plus ar squared and so on. That is the form of the sum of infinite geometric progression. So we use the formula of sum to infinity, that is a over 1 minus r, and then we find the value of r using the second and the first term, that is ar over a, and then we will get 0.01 for r, value of r, and then we substitute into the formula, and then we will get the answer is 25 over 99.
Next, express the repeating decimal 0.56263 in the form of sum to infinity of geometric progressions. Hence, express the number in the simplest form of fraction.
Before this, we have learned to solve the simple recurring decimals. So this time, we are going to learn how to express the repeating decimals that contain other number, such as in this question we have 0.5. So first of all, we need to separate the 0.5 and the 0.063 and 0.0063, and then we know that 0.063 plus 0.00063 and so on is the sum of infinite geometric progression. We use the formula of sum to infinity, that is a over 1 minus r, and then we will get 1 over 2 plus 7 over 110. The final answer is 31 over 55.
So, a wire is cut into a few in which 10x cm, 4x plus 20 cm and 3x minus 10 cm are the three consecutive pieces of geometric progression. First question,
find the longest piece if 10x is the second longest term. We know that in geometric progression, the first term is the longest or the biggest number. So, how can we find the longest piece if the other terms are having variables? So, the first step is we need to find the value of x and then substitute to get the exact number for the second and other terms. Since we have second, third and fourth term for the geometric progression, we use the formula of common ratio to get the value of x. So, T3 over T2 equal to T4 over T3. We applied the cross multiplication method and then we will get x equal to 20 and x equal to negative 10 over 7. We substitute x equal to 20 into the progression for getting the exact number for each term. Why we not use negative 10 over 7? Because people is not cutting wire in the form of negative. We are going to find the longest piece, that is T1, or as known as A. The first, before we are going to find T1, is we are going to find R. After we get R equal to 1 over 2, and then we substitute in the formula again, and then we will get A is equal to 400. Second question, if the wire is cut into sum to infinity pieces, find the maximum length of the wire in meter. So we use the formula of sum to infinity, that is A over 1 minus R. We know that R is 1 over 2 and then A is 400. So we substitute in the formula and then we will get 800 cm. But the question want the answer in meter. So we divide by 100 and then we will get 8 meter for the final answer.
For the first question, find the number of bounce when the maximum height of the ball from the floor is less than 50 cm for the first time. So for the first height, h equal to 0.8 h. From the situation, we know h is 200, so 0.8 times 200 equal to 160 cm. For the second height, equal to 0.8 times h1. h1 is equal to 160, so 0.8 times 160 equal to 128. To find the third bounce, we can see the sequence from the first bounce is 0.8 times height and the second bounce 0.8 times height 1. So to find the third bounce, 0.8 times height 2. So 0.8 times 128 equal to 102.4. Next, to identify whether this is arithmetic progression or geometric progression by find the common ratio. If there is a common ratio between the number, then this is geometric progression. So for the first step, Tn is less than 50. We know Tn equal to ARn minus 1. So just substitute the value A equal to 160, R 0.8, and N is an unknown because we don't know the number of bounds. So bring 160 to other sides and we simplify to get 5 over 16. So now n minus 1 is the power. To find value of n, we have to bring down log 10. So we can see there is third law of logarithm. Next, bring log 0.8 base 10 to the other side. So it will be log 5 over 16 base 10 divided by log 0.8 base 10. And the symbol must change. So the answer of n will be n equal to 7. To check your answer, you can substitute the value of n equal to 6 into the formula AR power of n minus 1.
and you will get 52 more than 50. If you substitute the value of n equal to 7 into the formula, and you will get 52 less than 50.
So for question B, find the total distance in cm traveled by the ball until it stops. So for the first step, we have to use the formula sum to infinity, a divided by 1 minus r, so just substitute the value 160 divided by 1 minus 0.8 and we will get 800 cm. For the last step, the total distance equal to 2 times 800 plus 200 and the answer will be 1800 cm.